Hello, I'm Pappy Bedard, and welcome to another one of my tutorials. In this tutorial, I'm going to show you how you can write a little bit of Python in a script to load gradient files into Cinema 4D, specifically GIMP gradient files. The code I'll be using should be compatible with version R20 and up. I'm using R23 for this tutorial. It's also possible it'll work with R19 if you leave out a couple of lines. And I will put some comments in the code that I post so you can tweak it if you have R19. This is the kind of tutorial that you won't find useful very often, but when you do, I think it'll come in handy. So hopefully you'll learn a trick or two, and let's get started. So here's what I would like to do. I would like to go online and browse gradients, find one I like. Oh, here's a good one. Download the source for that gradient. I'll save that. It's called Abstract 3. Let's back up, take a closer look at what that's going to look like. And then I would like to click a button and load that gradient I just downloaded. And there it is. Just so you can see, it's the same. So I'm going to show you how to do that. We're going to be creating a Python script that will allow us to load a GIMP formatted gradient. So what is a GIMP formatted gradient, and why did I pick that format? Well, let's look at this site. This site here, CPT CITY, has a whole collection of gradients. It's an archive of gradients. And what I did is I looked, they actually have many different formats of gradients in here. So I'm going to go back into that folder I was in and click on that Abstract 3. You can see that these are all the different formats of the gradients that you could download. This is one of the formats that they have. Here's another one, C3G. Here's another one, GGR, which is a GIMP gradient, which I like the format of this because it seemed like it would be easy to parse this and read it. So without getting into all these other formats, let's just say that this is the one I'm going to use. Now, what is GIMP? GIMP is the GNU image manipulation program. It's a cross-platform image editor. And I believe it's open source, so it seems like this would be a good choice. Now, let's take a closer look at what this format is. So I'll browse over to the file I downloaded and open it up. And I'm going to load a background to make this easier to look at. So the first, well, here's a description of what a GIMP gradient format looks like. The first line is always the word GIMP followed by gradient. The second line is the word name, colon, followed by the name of the gradient. The third line is the number of segments. And then there's each line has the segments. The first column is the left position of the gradient. So let's see if I can relate that to what we have here. I'm not sure I can do this all on one screen. we don't need that anymore. So here's a knot, and the knot's position, the first knot's position is 0, and it extends all the way to 43%, which if you look at the thing here, it's at 43.573%. Let's take a closer look at this and show the sub-channels. So I'm going to go ahead and undock this window. Let's get this out of full screen mode and just move it out of the way. And then we'll bring in our documentation windows. So if you look down this list, you can see that each of the nodes has a number 1 through 7. Each one has a color, a brightness, a position, a bias position, and an interpolation. So you could see that the knot position is 0 on the first one, 43 on the second, 59 on the third, and so on. Well, that exactly corresponds to 0, 43, 59, and so on. So the first column is the knot's position. And the third column is how far it is between that knot and the next one. You see, what this does is document segments, whereas we're dealing with knots. So each segment is surrounded by 2 knots. So the first segment is 0 and it goes to 43. The second segment is 43 and it goes to 59. So you notice that this number is the same as this one. Okay? And then this number in between is where is the position of this little bias point. That's the bias position. Now, why doesn't that seem to match? 11.49%. Well, if you calculate the distance between this and this, it's 0.435726, right? Because it starts at 0 and ends at 0.43. Well, where is 0.05 in relation to that span? Well, it's 11% over. And we're going to do a little math to figure that out. The next 3 numbers is the color. It's really the RGB that's been normalized between 0 and 1. So that we can handle. This is actually the alpha. If it's 1, it's completely opaque. If it's 0, it's completely transparent. And we're not going to, I'll get into that a little bit more later. That's not one of the 5 parameters that we have for each knot. The second batch of numbers is the color that the segment ends with. And in this case, this color is exactly the same as this one. So in other words, this segment, the first segment ends with this color. The second segment begins with that color. Seems redundant, but there are cases when that's not the case. So that would be the color. The second color is this. This column is the alpha value for the right color, or the alpha value at the right end of this segment. And then down here I talk about blend functions and color type. Well, that's what these 2 little columns are. That column here is the blend function. That would be like this linear. This we have to do a little conversion for because these numbers won't match the Cinema 4D numbers that represent these, but I'll get to that also. And then the color type, the final column, is either 0 for RGB, 1 for HSV counterclockwise, or 2 for HSV clockwise. I'm just going to always assume it's RGB. I've never seen a GIMP gradient that didn't have RGB as the color type. So we're just going to leave that as is and assume it's RGB. So that's the format of the GIMP gradient. So what we're going to do is write some Python code in a script that reads this file, and then it will create a null object. It'll add user data, which is a gradient, and then it'll set all the values of this gradient to match what's in that file. So I'm going to go ahead and close Cinema 4D, and we will start from scratch. Okay, so here's our fresh copy of Cinema 4D, and we are going to go into Extensions and Script Manager. And if you have a different script in here, you can always click this first button to create a new script, and it starts by creating a little hello world example. And I'm going to get rid of most of this except for the execute main maybe. And all right, so we need to import Cinema 4D, and we need to import OS. You'll see why in a minute. And from C4D, we will import storage. This will allow us to do our first line of code. So we need to define the main procedure. And all right, so we're going to start out by loading that file. So file, or asking the user to find the file. We'll present a load dialog. This load dialog is a function inside of this storage. It takes some parameters. The title, well, let's say that's select GIMP gradient file. And we'll put a flag on here. C4D file select load. All right, so that by itself will just bring up a dialog. We can test this right now. Let's just see if that works. We'll hit execute down here, and it brings up a dialog, and there's that file I had downloaded. So cancel this, and let's continue. We need to create a gradient to eventually put that stuff into. So we're going to create a C4D gradient. And here's why I imported OS. I want to grab the name of that file and set a variable called name equal to OS, that's the library, path, base name, file path. So file path is this variable. I'm passing that into this base name function to extract the name. So the name will be something.ggr to start with. Then we're going to open the file. Give it the path, and we're going to open it for reading. And then we're going to have some code, and then eventually we're going to close the file. If you don't close the file, it kind of stays locked open until you close Cinema 4D. So I'm going to always make it a habit to start with open and close like that so you won't forget. Now, one of the things I know I'm going to have to do is collect some knots from that file. So I'm going to create a list called knots and just set it to a blank list for now. So we're going to fill that list when we read this file. So that you don't have to watch me type every single thing, I'm going to cut and paste some stuff. So we're starting here, and it says for line in F. So that's for every line that we read out of the file F. If name in lowercase is in the line, then we split that line at the colon and take the text to the right of the colon and strip the quotes off it, and that'll be our new N. That'll be N. And if N is not blank, then we'll make the name N. So what that little bit of code is for is that we're going to start out by assuming the name of the gradient is the same as the file name. If, however, there is a name in the file, we're going to use that name instead. So that's all that does. So let's go to the next line of code. Here what I'm going to do is create a list called LData by splitting a line by its spaces. So LData is going to be a list. If LData is on this first line, it would be a list with 2 objects. This actually, because there's a space in the name, would have 3 objects. It would be name, colon, abstract, and 3. The next one would be 1 item in the list. But if it reads a line like this, that LData is going to be a list that has these 13 columns in it. So we're going to use that fact and say if the length of that list is greater than or equal to 13, we are going to start taking some I have an extra, got to watch out for how we indent these things. This if only applies to the name. LData is part of this for line in F, and so is this. If the length of LData is greater than or equal to 13, well, we're going to create a variable called left, and that's going to be the LData. It's going to be this. That's going to be left. That's item 0 in the list LData. This is item 1. This is item 2. So item 2 is the right side. So we have left and right so far. So we're just going to keep going and parse out all of these different columns. The bias I said was a little different because we can't just use that value. We have to calculate what percentage it is between the first and the last item. So I'm going to do it this way. Hope you don't mind that I'm not typing every letter here in front of you. So we'll start out by setting a value B to be that data that is in the second column. And then we're setting bias to be B minus left. I could kind of show you that maybe if I use Doodle. So let's see. I use Doodle Paint, and then so this is left, and this is right, and bias is somewhere in the middle. So I want to find out what percentage this is of this. So if you look at the code, I have B minus left, which is this small arrow distance. divided by right minus left, which is the whole distance. So that'll just give me the percentage. So that's where that math comes from. Okay, so that gives us the bias. Now we need the color and the alpha. We're not going to use the alpha, but all right. So the color left is just, we're converting into a C4D vector the data that we find on these three columns. So that's L data 3, 4, and 5 for the left color. And then there's the alpha for the left. And then there's L data 7, 8, and 9 for the right color. And then there's the alpha for the right. Finally, we're going to grab the interpolation. And that's going to be that last column. And we're going to forget about the color type. Just going to assume that's always RGB. All right, so we have all our data in these variables from this line that we're on. And next, we're going to put that data into some knots. So remember, knots was an empty list. Well, I'm going to append the left color, the alpha left, the left position, the bias. 0 is just a placeholder. That's going to contain the node ID eventually. And the interpolation. Now we might have to do some work with interpolation because I know already that the interpolation in the file doesn't match the number that we need for Cinema 4D. So I think that's all we have. Whoops. Deleted that by mistake. All right, so we open the file and we read everything from it, and then we close the file. Now, what do we do with that? Well, what we're going to do is for every knot in knots, we are going to do something to our gradient. We're going to insert a knot. And that takes some parameters. This might be a good time to show you the official Cinema 4D Python documentation. What we're going to do is search for gradient and see how we insert a knot. Right here is the insert knot. So it takes color, brightness, position, bias, and index in that order. I'm just going to copy that, paste it here with a comment line in front of it. So what is the color? It's going to be KT, that's the knot we're dealing with, and it's going to be, color is the first one, so that's 0. Next is the brightness. We're always going to make the brightness 1. I'll put some spaces in here, make it a little easier to see. Now, next we need the position, which is the second. This is 0, 1, 2, 3 is the bias, and 5 is the interpolation. Well, so the bias is 3, KT3. And you notice that there is no interpolation parameter for inserting a knot. We're going to have to deal with that later, but for now, let's just leave it at that. So now we need to add a new null, and name it the same as the gradient. This is the way you add a null. C4D baseless 2D, C4D dot O null. O is for object. You could add a cube by saying O cube, and so on. So we set the name of this new null we just created to be the same name that we came up with up here. So that'll be the name of the null, and then we insert it into the document. Now we need to create some user data. So I've got a comment here. Create a new base container for the gradient user data. So we'll say BC is the base container. And I'm going to use this crazy function here to create a custom data type for gradients. And then we are going to set its name, BC name, to be equal to the same name as what we've been using. Now we're going to grab a description. We're going to set a description ID. This would be the ID of the object that we're creating, the parameter in the user data. That ID is going to be equal to the new null, but we're going to add user data, that base container. So when we do that, it'll create a new, I think I got the case wrong. I think it has to be like that. Yep. So that adds a gradient user data type and assigns it description ID. Now we need to set the parameters, all of the colors and nodes and everything, according to so new null description ID, that's the parameter in the user data. We want to set all of its values equal to what is in gradient. And then finally, we need to add an event to make all that happen. So let's see. Let me get rid of that comment. So this is maybe a good first pass. Let's execute this and see what we get. So it brings that up. I'm going to grab that abstract gradient and open it. It created a null, and it created a user data that has a gradient in it with the same name, abstract3, and it has some nodes. Now, one of the things, I'm not sure you can see it, but these nodes seem to be doubled up, which they are. If you remember when we were looking at the, let's see if I can find it. When we're looking at this data, this position, okay, this position here, 43%. So what we did is we added a node at 0, then we added one at 43%, then we added another one at 43%, then we added one at 59, then we added another one at 59. So this gradient is technically correct looking, but it's got more nodes than it needs to have. So we're going to optimize this a little bit in part 2. So how could we optimize this thing? I'm going to go ahead and undock this, and let's take a closer look at this by showing the subchannels and looking at these knots. So I could see that the node we have at 2 is the same color as the node we have at 3. and it's exactly the same position. So we don't want to include a knot if the color and the position is the same as the next knot. So we could delete this knot here. So this is knot 3, I believe. Yeah, knot 2. Knot 2 is the same as 3. Same color, same position. So we're going to just delete knot 2. I'm going to hit delete. And notice it didn't change anything. So it's the same with knot 4. It's the same color and position as knot 5. So I'm going to select that one and delete it. Again, you could see that it didn't change. Same with this one. Same with this one. Same with this one. And that's it, I believe. So what we're going to do is only add these knots in if they don't match the same color and position as the next knot. So we're going to add a little loop here. All right, I'm going to copy all this code and then I'll talk about it. So before we, right now we're including all the knots. We're saying for KT and knots, insert it. We want to change that. So I'm going to overwrite this with this. Okay, it's a little bit longer. And let's talk about this. Whoops, I'll just line things up here. So I want to keep track of which ones I've included to be used later, and that'll become clear. So what I'm going to do is, instead of saying for KT in knots, I'm going to say for I and KT in enumerate knots. This is a handy little piece of Python that you can use if you want to keep track of the index of each item in the list as you're going through it. So we're going to start out by setting a variable called include and say that's true. So we're going to, by default, we're going to include it. Well, we always want to include the first and last knot because we don't want to start with no knot or end with no knot. So we're going to always include those two. The length of the knots -1 is the value of the index if it's the last knot. So if it's the first or last knot, we're going to include it. But if it's not the first or last knot, what do we want to do? I have a little too much code in here. I can clean this up. So I've got this comment here. Do not include if the color is the same as the prior knot and it's a new position. Well, this would be in the case of a gradient that has like stripes of colors. And I'll demonstrate that after we get this working. And we also don't want to include if the color and position is the same as the next knot. So that's the one we just figured out here. So if knots I, which is the knot that we're dealing with, if it's 0, that's the color, is the same as knots I+1 color, and knots I2, which is a position, equals knots I, which is the I+1, which is the next knot, 2, which is the position. So if the color's the same and the position is the same, then set include to false. And then finally, if we include it, we append the index to our list of included indexes, and then we insert it. So it's only going to be inserted if it matches these cases. So let's go back to the view like this, and let's see, can I just dock that back in here somehow? Yeah, close enough. All right, so here's our abstract 3. Now let's run this again and load the same one, abstract 3. So here's the new one. And now, well, I'll split it off again. Now let's see what it has for subchannels. See, they're all different colors, so that worked. And that looks just like the other one. Let's test this out with maybe another gradient. So let's go find one here. Let's see. And well, let's see. How about we find a simple one? Selected 5 color palettes. Oh, how about this one? Adrift in Dreams. Let's take a look at it. You could see that it begins with the same color and it ends with the same color. Then the second one has a new color and it's the same color. And then the third one is a new color and it's the same color. So this is why I put that logic do not include if the color is the same as the prior knot and it's a new position. So this color is the same as the prior knot, but it's a new position. So we don't need to include this second knot. So that's what accounts for these two pieces of logic that say don't include. So let's test this one. So I'm gonna right click on it, save as, and we'll save it in the same folder here called Adrift in Dreams. And let's execute this and grab Adrift in Dreams and see what that looks like. Well, okay. Something seems wrong. Adrift in Dreams is supposed to look like this, not like that. So what's wrong is the interpolation. Now I can correct that by selecting all of these and changing the interpolation to step. Now you can see that it's the same. So that's the next thing we have to do, is figure out how to fix all of our knots by adding the interpolation. Now, all we did is grab the interpolation here, but we never did anything with it because the gradient insert knot didn't have an interpolation for parameters. So what we have to do is something a little trickier. So that'll come next. Before I go any further here, I think we should save this. So we're going to save the script as, and this automatically defaults to your script library. I'm just going to call this gradient tutorial .py so I can find it later. Okay, I'm also going to go ahead and reset my startup layout. And let's talk about what are the parameters that we can set in inside of this gradient object. I'll change this back to this. So if we go into console Python, we can drag this object over here and then hit enter, and it tells us that it's a gradient. Well, how can we grab parameters and change parameters from that? Well, I'm going to hit up arrow. I'll set a variable gr equal that. So now gr is a gradient. Now, we can get data from a gradient. So I'm going to refer back to the help. And let's see. We can get data. And depending on what parameter we give it, we'll get different information. So there's 3 parameters that we can use there: gradient not, gradient mode, and gradient unclamped. So let's just do that. So if we say gr.getData and pass it c4d.gradient mode, you got to spell it right. Tells us that the gradient mode is 0. Okay. And the other one was unclamped. That one's 0. Now, gradient not is actually a whole collection of things. So I'm going to go ahead and set a variable. Say gk for gradient knots equals get data, and we'll change that to not. This is how we're getting data. So now gk, it's a base container, which means we could do something like this. For I, j, in gk, print I, j. Let's just see what's in there. Well, I is always 0, and j seems to be another base container. Well, let's expand on that one. So I will copy this, paste it here, and add another line. So now I'm going to drill into j. So we'll just say for kl in j, print k and l. Let's just see what's in there. Interesting. So this actually is all of these parameters. So this is the color. 1 is the brightness, that's 100%. 2 is the position of the knot, 0. 3 is 50%, that's the bias position. 4, that's just the index, that would be this index 1, 2, 3, 4. And 5 is the interpolation. So step is parameter number 1005. Let's see. If I do this little bit of code, first of all, there is lots of places we use things like C4D dot and then some text and it represents something. Those all come from a C4D dictionary. So what this little bit of code does is that for every D, every item, every definition in all the dictionary items, I want to find anything that has the word gradient in it. So this lists some things. So let's see, what is 1000? 1000 is the color. Yeah, it's right here. The gradient not color is 1000. 1001, we know that's the brightness. That's this one. 1002, well, we know that is the position right here. 1003 is the bias position right here, the bias. 1004 is the ID, and 1005 is the interpolation. Here it is. Not interpolation, 1005. So, well, this is one way of searching. When we write code, we don't want to actually ever hardwire 1005 when we mean gradient not interpolation, because in subsequent versions of Cinema 4D, they may decide internally to change that number. So we always want to kind of refer to it as this. Gradient not interpolation with a dot, with a C4D dot in front of it. Now, what are those interpolations? Like, what is 5? Well, we know it's step. And that is right here. None. It's like no interpolation. It's just a step. So these are the interpolations that we have to map to the values we find in the GIMP file. So here's an example of a GIMP file. The interpolation is all 0. Well, 0 is actually a cubic knot. That's not what we want. Okay. So I've already kind of worked out the code. So let's go back to our script manager and paste in some more here. Let's see if I can find it. Okay. I'm going to define a function up here above main. And here's what it does. It's going to take a number. That's the interpolation we read out of the file. And it's going to interpret it based on this if-else statement. If it's 0, it'll make it linear not. If it's 1, it'll make it smooth not, and so on. But I had to add one more thing. We're going to also pass the left and right color. And if the colors are the same, we're going to also make the interpolation none. And then in our code here, where I just simply read the interpolation, I'm going to change that so that instead of that, it's going to call that function and pass it the data we find in the file and then the left and right colors. So that gives us the correct interpolation. But now how do we modify the knots and add that interpolation in there, since there didn't seem to be a way to do that? Well, here's what we're going to do. I'm going to, similar to what I did in that sample over here with the console, remember I dragged the I dragged the gradient. I defined a gradient as our data, and then I used the get data to get the knots. So here I'm getting the knots with GK, that's the gradient knots, and then I'm enumerating through all the knots, and I'm changing its interpolation to the interpolation now we have in the knots. And then finally, I'm setting that data back into the gradient. So let's see if that works. Close some of these windows. So I'm going to reload Adrift in Dreams again. Remember, I had changed, these were all smooth, and that was incorrect. So I'm going to execute this, reload. Where are they? Gradients. Adrift in Dreams, and see if we can get, aha. So now this is correct. So it applied the correct interpolation step for these. So now we can load those two types of gradients. But there's another type of gradient that includes alpha channels. And I want to show you how we could deal with that, partly with code and partly with some manual manipulation. So let's go back into these GIMP gradients, and here's an example. I want to use square wood frame. Let's take a look at that one and download it. And let's just see what happens. I'll just leave that there so we can refer to it. So what happens if we just run this and on this and see square wood frame? Well, we seem to get what we want, but this first part is all brown, and that should be invisible. But there seems to be no way to adjust it the way we've got this set up. I'm going to right click on here and go into Edit Entry. This actually edits the user data for this parameter. So what I'm going to do is go to Details and change this by adding color and alpha. And this opens up something else. It lets us edit alpha. First of all, I want to click here and copy this knot position. Then I'm going to edit alpha. We're going to add a knot here and then another knot here and paste that knot position and change this to step and this to step. And we're going to make this one 0 brightness. So that's going to be invisible and that's going to be visible. Now, if I display the result, that's what it's supposed to look like. The problem is I couldn't find any way using Python and the functions that Cinema 4D allows us to use to manipulate gradients to add a alpha channel. So we have to do it manually. But the thing I could do at very least is make it so that the user data has these two check boxes. So you could do this manually if you had to. So we will do that next. When we created that base container here, we set its name, but there's other parameters we could set. We could also set its gradient property, alpha with color, true, and gradient property alpha true. That directly relates to these two checkboxes. Every one of these would have another parameter you could set if you wanted to check other ones. In fact, when you're creating user data, there's lots of things you could do when you create it. So that will help us by creating it with the alpha data. So, and what else do we need to do? I think that was it. So let me just execute this again on square wood frame. Now again, it's not going to give us what we want, but at least we would have this edit alpha option. There's one more thing we need to do. We don't want to have to load this script each time. Whoops. So before I go any further, we'll save it. But right here where this little Python icon is, you could change that to a different icon if you'd like. but I'll just leave it. You can drag that up, put it in your interface, and then close this. And now anytime you want to load a gradient, you can click on that, load one, click open, and there it is. And finally, what you could do is save that as a preset. If you click Save Preset, you could name it Abstract 3. And then you would see that in your content browser. Well, better way to demonstrate that is, let me go to Adrift in Dreams and then load preset, and you should see there's Abstract 3. So CPT CITY was one place to get gradients, and it really is a pretty comprehensive library, and it allows you to view what they look like. So it's a really great resource. But you could also just search for GIMP gradients free, and there's lots of things you could download. Here's a package of 900 gradients that you could just download. It gives you all the GGR files. So it's just a matter then of browsing through them and checking them out. So with that, I would like to say thank you very much for sticking with me and for all the support you've been giving me. I can't believe I've got over 370 subscribers now. I started a year ago and I had 8. So it's been a great 12 months for me. And again, I appreciate your support, and I look forward to coming up with the next tutorial. See you then. Thanks again. Bye.